Look at this absolute value equation. Absolute value of x is equal to 4. What values of x make this equation true? Well, 4 makes this equation true, and negative 4 makes this equation true. The reason is because absolute value is the distance from 0 on a number line. And we know that 4 is 4 units away from 0, and negative 4 is also 4 units away from 0. For that reason, I can put a 4 and it's true. I can put a negative 4 and the absolute value of negative 4 is still 4. Following that same logic, look at this example. That means that I should be able to put an 11 inside that absolute value and it would be a true statement. I should be able to put negative 11 inside this absolute value and it would still be a true statement. So that's how we solve absolute value equations. You're going to break them into their positive and to their negative. So keep your 4x minus 3 just like it is. So 4x minus 3 can be 11, but 4x minus 3 can also be negative 11. Just solve each equation like normal. Add your 3 to both sides. Divide by 4. Make sure that you reduce your fraction or give it the nice 3.5 decimal. Here you're going to add 3 to both sides, divide by 4, and x is equal to negative 2. Let's look at the second example. This says the absolute value of 7x plus 1 is equal to negative 9. Well, absolute value is distance. Distance is always positive, so for that reason, this one has no solution. If you are still in the absolute value, you can't equal a negative. Now, if I break it out of its absolute value, as in here, then it can be a negative. All right, let's look at example 3. The first thing that you have to do is you have to isolate. So first, isolate your absolute value. That means I have to get rid of that 3. It's attached by multiply, so I know I need to divide. So the absolute value of 5x plus 2 is equal to 12. Now I'm going to break it into its positive 12 and break it into its negative 12. So 5x plus 2 is equal to 12, and 5x plus 2 is equal to negative 12. Solve each equation like normal. Subtract your 2, divide by 5, and x is equal to 2. Over here, subtract your 2, and 5x is equal to negative 14, and then divide by 5, and you get negative 14 over 5, or negative 2.8 as a decimal. Okay, example 4. Let's isolate first, because that's what you have to do first, is isolate, and then you break. Isolate, then break. So if that's a plus 6, we need to subtract 6. Now my absolute value is all by itself, but the problem is absolute value, when it's still in the absolute value symbols, can't equal a negative. So this one has no solution. Example 5. All right, we know what we have to do first. First, we have to isolate. And when we do isolate, then we want to make sure it's equal to a positive, and if it is, then break. Isolate, then break. So on this one, I'm going to add 9 to both sides, And so if I add 9 to both sides, that's going to give me 35. So 5, the absolute value of 2x minus 1. Now divide, because it was attached by multiply, so do a division. And you get 7. Now we can break it to the positive side and break it to the negative side. Notice that the only thing that you're changing is your 7. The 2x minus 1 is going to stay the same. This right here, whatever's in your absolute value, stays the same. So it'll be 2x minus 1 equals 7, but that could also be a negative 7 and be true. So add your 1, divide by 2, and x is equal to 4. Add your 1, negative 7, plus 1 is negative 6, and x equals negative 3. All right, let's look at example 6. In this example, we have variables on both sides. When you have variables on both sides, you must check your answers. You have to check your answers. That's because you're introducing an unknown over here on this side. Therefore, it changes what could be happening. But we're still, if this is isolated, we're still going to break it into the positive and break it into the negative. So 3 plus x is equal to 2x plus 9. That's the positive. Just keep it like it is. Then over here, 3 plus x equals negative 2x minus 9. When you negate all the signs. So you're going to take this side right here, make that turn to the opposite, and make that turn to the opposite. All right, solve your equations just like normal. So I'm going to subtract my 2x over. So I have 3 minus x equals 9. Subtract your 3 over, divide, and x is negative 6, or we hope. We're going to have to check that. Here, I'm going to add my 2x over. So as I add that over, I'm going to have 3 plus 3x equals negative 9. Don't lose your face with your body. Subtract your 3. So negative 9 minus 3 is negative 12, and divide, and you get x is negative 4. And again, we have to check these. When you check this, you go back to the original problem. Take your first answer, which is negative 6, and put that in on both sides. And just make sure that you get a true statement. You can either do this mentally, or you can use your calculator and use your absolute value buttons. So here on this side, I have 3 plus negative 6, which is going to be the absolute value of negative 3, which is 3. Then that's going to be negative 12 plus 9, which is negative 3. And those don't equal, so therefore this answer does not check. Do the same thing on the other side, going back to the original problem. So 3 plus negative 4 equals 2 times negative 4 plus 9. This is going to be negative 1, and the absolute value of negative 1 is positive 1. And over here, negative 8 plus 9 is 1. That's a true statement. So this one checks. And you want to check, sometimes you have to throw both answers out. Sometimes you get to keep both answers, and then sometimes you keep one and don't keep the other. It's just the nature of each problem. Let's take a look at number 7. On this one right here, we can break it into its two parts. Break it to the positive and break it to the negative. So I'm going to have 3x plus 1 is equal to 2x minus 5, just like it is. Then I'm going to say 3x plus 1 equals, and when I'm negating this, that's a plus 2, so now it becomes a negative 2. That's a minus 5, so now it becomes a plus 5. Remember, when you negate it, you have to negate all the signs. All right, solve each one. So I'm going to subtract the 2x, subtract the 1, and x equals 6, but we'll check to be sure. Add your 2x over, subtract your 1 over, divide, and either get 4/5 or a 0.8. 0.8 may be easier to check, especially if you're checking on the calculator. So I'm going to go and check my -6 first. And if I check my -6, I'm going to find out that I got 17 on this side, but I get a -17 on that side. So this answer does not check. I check the 0.8. When I check the 0.8 on this side, I get 3.4. When I check the 0.8 on this side, I get -3.4. So this one doesn't check either, and this problem has no solution. All right, last one. So the first thing we have to do is we have to isolate that absolute value first. So if this is a 1/2 or a 1 divided by 2, I have to multiply by 2. But if I'm going to multiply this by 2, I have to be fair and multiply each of those people by 2. So those 2's cancel, and I have the absolute value of 3x plus 5 is equal to 12x plus 8. Now that it's isolated, you isolate, then you break. And so I can break it to the positive, and I can break it into the negative. So that's going to be 3x plus 5 is equal to 12x plus 8. And then on the negative side, 3x plus 5. And remember, you have to negate them all. So I'm going to make this turn into a negative 12x, and I'm going to make this turn into a negative 8. Solve each equation just like normal. Subtract your 12 over. So if I do that, I'm going to have negative 9x. Subtract your 5 over, and you'll have 3. Divide by -9. Be careful, because sometimes you want to say 3 goes into 9, but in reality, this is 3 divided by. And you get x equals -1/3. Here, add your 12 over. So 3x plus 12x is 15x. Here, subtract your 5 and watch your signs. -8 minus 5 is -13. Divide by 15. And x equals -13 over 15. And once again, because there's variables on both sides, we have to check these answers. When you check your answers, you're going to go back to the original problem. You're going to put an x on this side, and you're going to put the -1/3 in on that side and see if you get a true statement. When I put -1/3 over here, I'm going to get that I get a 2. And when I put -1/3 over here, I also get 2. So this one checks. Now on the other side, this one right here does not check. One side does not equal the other side. If you need more help on absolute value equations, be sure to check out my practice worksheet video. There you can try problems on your own, pause the video, check your answer, and then watch my explanation. I hope to see you soon.